Welcome to the deep dive. You know, it feels almost like magic, doesn't it? You pull out your phone, tap an icon, and bam, you're watching a live video feed from a camera maybe thousands of miles away.
It really does. But behind that magic, there's some seriously clever software doing the heavy lifting.
Totally. And that's what we're digging into today. We're moving past the camera hardware itself, the lens and all that.
Right. We're focusing on the IP Camera Viewer app. This is basically the command center, the brain of your modern surveillance system.
Exactly. It's that application, whether it's on your phone or your computer, that doesn't just show you the live feed from your network cameras. It manages, well, pretty much everything related to them.
It really does. It's essential for any kind of remote monitoring.
So our mission today is pretty simple, really. We want to understand the mechanics. How does it actually work?
Yeah, not just knowing that it works, but getting into the nuts and bolts. How does that app securely connect? What are the protocols? How does it handle things like firewalls?
We want to go from just being a user to someone who actually gets the underlying tech, sort of like looking under the hood.
Okay, so let's start right at the beginning, that initial connection. If I've just plugged in a new camera, what does the app need? What are those key pieces of info?
It's got to be more than just the camera's brand name, right?
Yeah.
There are some core network details involved.
Oh, absolutely. Think of it like 3 pillars. First, you need the camera's unique IP address.
Okay, so that's its address inside my home network.
Exactly, like its street address on your local Wi-Fi. Every connected device has one. Second, you need the specific port number.
Right, if the IP is the street address.
Then the port number is like the specific apartment door or maybe the specific service window you need to go to. Port 80 is usually for web stuff. Maybe port 554 is for the video stream itself. It directs the traffic correctly.
Got it. Directs it to the right application on the camera.
Precisely. And the third pillar, obviously crucial, is security. The login credentials. Username and password. That authenticates you.
Okay, so IP address, port number, username, password. The app has those. Now, how does it actually, talk to the camera? What language is that video stream speaking?
Right. So that's where standard streaming protocols come in. And the big one here is usually RTSP.
RTSP.
Yeah, real-time streaming protocol. It's designed specifically for, real-time stuff. Low latency video and audio over a network. If you tried using standard web protocols like HTTP, the lag would just be unusable for live video.
Makes sense. You need that immediacy. So RTSP handles the actual stream efficiently. But you mentioned standards. There's another acronym that always comes up. ONVIF. Why is that one so important?
ONVIF. Yes, that's the Open Network Video Interface Form. Huge deal. Before ONVIF, it was often a bit of a mess.
How so?
Well, you'd buy a camera from Brand X, and you had to use Brand X's recorder, Brand X's app. Everything was locked into their own little ecosystem, walled gardens, basically.
Right, no mixing and matching.
Exactly. What ONVIF did was standardize things. Not just the video stream itself, but also crucial stuff like how cameras are discovered on the network, how you configure their settings, how events like motion detection are reported. It created a common language.
So ONVIF is kind of like a universal translator for security cameras.
That's a great way to put it. It allows cameras and software from different manufacturers to actually talk to each other and work together properly.
Which basically enabled the whole market for third-party viewer apps then. The ones that aren't tied to a specific camera brand.
Absolutely. Without ONVIF, those apps would have a much, much harder time existing. It provides that baseline compatibility.
Okay, so that sets up how things connect generally. Now let's talk about where you are when you're viewing. There's a big difference between watching the feed when you're on your home Wi-Fi versus when you're out.
Oh, huge difference. Let's start with the easy one, local access.
That's me on the couch, phone connected to my Wi-Fi.
Exactly. Your phone and your camera are on the same local network. They can talk directly through your router. The connection is fast, direct, and pretty secure because the data doesn't even leave your house. It stays within your private network.
Simple enough. But then I walk out the door. My phone switches to cellular, or I jump on the coffee shop Wi-Fi. Now what? That connection has to go out onto the big public internet.
Right.
And somehow find its way back through my router's firewall to reach that specific camera inside my home network. This seems like the tricky part, the technical hurdle.
It is, and this is where we see two main ways, two primary methods that apps achieve this remote access. This is really the aha moment for a lot of people.
Okay, lay it on us. What's the first method? You mentioned one was easier.
Definitely easier for the user, yeah.
Yeah.
That's PDP, or peer-to-peer networking.
Yeah.
This is what most consumer-grade cameras use by default these days.
PDP. And why is it easier? Does it mean I don't have to mess with my router setting?
Exactly. That's the key selling point. Zero router configuration needed from you.
Okay, how does that work then? How does it get through my firewall without me opening a door for it?
It uses a kind of digital middleman or maybe a concierge service. It's usually the camera manufacturer's cloud server.
Oh, okay.
So when your camera starts up, it phones home, it connects to that manufacturer's cloud server, and registers itself with a unique ID.
Right.
Then, when you're out and about and you open your viewer app, the app also contacts that same cloud server. It says, hey, I'm looking for camera with ID XYZ.
And the server connects the dots.
Precisely. The cloud server acts as a matchmaker. It helps your phone and your camera find each other and establish a connection path even through firewalls. It sort of punches a hole through, but in a managed way.
So the manufacturer's server sets up the meeting.
Yeah.
But does the actual video stream go through their server too? That sounds bandwidth intensive.
Good question. Ideally, no. The server facilitates the initial handshake, but then it tries to establish a direct peer-to-peer connection for the actual video stream between your phone and the camera. Ah, okay. So the heavy lifting, the video data, flows directly if possible.
Right. The convenience factor is massive. But, and this is important, there's a trade-off.
Which is?
Your ability to connect remotely is entirely dependent on that manufacturer's cloud server being online and operational.
Mm-hmm.
If their server has an outage, or worse, if the company goes bust.
My remote viewing stops working, even if my camera and internet are fine.
Exactly. You're reliant on that third party. And from a security perspective, some people worry. If that central P2P server were ever compromised,
it could potentially map out where all the connected cameras are located. Okay, so P2P is easy, but relies on the cloud and has potential dependency and security angles.
it's a balance, convenience versus control and reliance.
So what's the alternative? The more technical path?
That would be port forwarding, often used in conjunction with something called DDNS. This is definitely more hands-on, favored by tech-savvy users or businesses wanting more direct control. Right, this is where you hear terms like router configuration, firewall rules, NAT. It can sound intimidating. Can you break down port forwarding simply?
Sure. Essentially, with port forwarding, you manually configure your router. You go into its settings and create a specific rule.
A rule that says?
A rule that basically says, hey, router, if any traffic comes in from the outside internet trying to reach a specific external port number, let's say port 50,000, I want you to forward that traffic directly to the internal IP address and the specific internal streaming port of my security camera.
So I'm deliberately opening a specific door in my firewall just for the camera's traffic.
Exactly. You're creating a dedicated path. It's direct, unmediated access from the internet straight to the camera. No third-party cloud server involved in the connection path itself.
Okay, that sounds like more control. But wait, don't home internet IP addresses change sometimes? My ISP might assign me a new public IP address tomorrow.
Yes. The dynamic IP problem. You're absolutely right. Most residential internet connections have dynamic IP addresses that can change without notice.
So if my public IP changes, that port forwarding rule I set up is now pointing to the wrong address, right?
Correct. And that's where the other acronym comes in, DDNS, which stands for Dynamic DNS.
Dynamic DNS, what does that do?
Think of DDNS as a service that constantly keeps track of your changing home IP address. You sign up with a DDNS provider, and they give you a fixed host name, like mycamera.ddnsprovider.com.
Okay, like a web address.
Exactly. And you run a little piece of software, maybe on your router or your NVR, that constantly tells the DDNS service what your current public IP address is. So that host name always points to your home network no matter how often the IP address changes.
I see. So when I'm remote, my app connects to mycamera.ddnsprovider.com. DDNS tells it my current home IP, and then the port forwarding rule on my router takes that connection and sends it straight to the camera.
You've got it. That's the complete picture for the manual method. Port forwarding handles the path through the router, and DDNS handles the finding of your router on the internet despite a changing IP.
That definitely sounds more complex to set up. You need to know your way around router settings.
It is. It's the highest technical barrier, for sure. But the payoff is potentially lower latency because it's a more direct connection and complete independence from any third-party cloud service for the connection itself. For some, that control is paramount.
Okay, two very different approaches. Easy P2P via the cloud, or technical port forwarding with DDNS for direct access. So whichever way the connection gets made, the app starts receiving the data stream from the camera.
Yeah.
But that's not just raw video pouring in, is it? It's usually compressed.
Oh, absolutely. Raw video would be enormous, especially high-definition stuff. It has to be compressed using video codecs standards like H.264 or the newer, more efficient H.265.
Right, to make it manageable to send over the internet or even just over Wi-Fi without clogging everything up.
Exactly. So the app receives this compressed stream, and the final, really critical step before you actually see a picture is decoding.
The app has to unpack that compressed data.
Yes. It takes those efficient, compressed packets and instantly translates them back into the high-quality video frames you see on your screen. The app's performance, how smooth the video looks, how little lag there is, depends a lot on how well and how quickly it can do that decoding.
Got it. So, connection established, P2P or port forwarding, stream received, RTSP, data decoded, H.264, H.265, and boom, we have a live picture.
That's the core pipeline.
Okay, so we see the video, but these apps do way more than just display a feed. Let's talk about the features that turn this into a proper security tool. We don't need to dwell on just watching, but what about interaction and control?
Right. A big one for cameras that support it is PTZ control. That's pan, tilt, and zoom.
So when I swipe my finger on the app screen to move the camera's view.
Yeah, the app sends a command back to the camera, usually small data packets, just little instructions saying move motor X by Y mount or zoom level Z.
And that happens pretty quickly.
It should, yeah. It's usually sent alongside the video stream or through a separate control channel. A related, often underused feature here is PTZ presets.
Presets.
Yeah, instead of manually panning and tilting every time, you can often save specific positions, like preset 1 is the driveway, preset 2 is the front door. You just tap the button in the app, and the camera instantly snaps to that saved view much faster.
Ah, that makes sense for quick reactions. Okay, what about capturing things, like still images?
Simple but essential. Snapshots. Just grabbing a still frame from the live video feed, useful for saving a specific moment without recording video.
And then there's audio. Some cameras have mics and speakers.
Right. Two-way audio. The app lets you listen into the camera's microphone, and if the camera has a speaker, you can talk back through your phone and your voice comes out of the camera, like an intercom.
Handy for scaring off intruders or talking to the delivery person.
Exactly. Okay, moving into the more security-focused features, motion detection and alerts are fundamental.
Pretty much every camera app has this, right? It tells you when something moves.
It does. But the quality of the implementation varies hugely. Basic systems just trigger on any pixel change, which can lead to tons of false alarms, swaying trees, shadows, bugs.
Yeah, that gets annoying fast.
So better apps offer more control. Things like adjusting sensitivity levels, but more importantly, setting up masked areas or detection zones.
Masked areas.
Yeah, you can often draw boxes on the video feed within the app, telling the system, ignore any motion inside this box, so you can mask out that busy street or the neighbor's flickering flag, and only get alerted if motion happens in the areas you actually care about, like your walkway or porch.
That filtering is key to making alerts actually useful, not just noise.
Absolutely crucial for usability.
Okay, so motion is detected. What happens to the footage? We need to talk about recording and storage.
Right. The app usually acts as the interface to control where recordings go. It might record directly onto your phone or tablet storage.
Which probably fills up fast.
It can, yeah. More common setups involve recording to a dedicated device on your network, an NVR network video recorder. It's like a specialized hard drive just for your cameras.
Or the cloud.
Or, increasingly popular, subscription-based cloud storage. The footage gets uploaded directly from the camera to the manufacturers or third-party servers. The app manages those recordings wherever they are.
And once it's recorded, you need to be able to find and watch it.
Which brings us to video playback. The app needs a good interface for browsing through those recorded archives. You don't want to scrub through hours of footage.
So usually links to the motion alerts.
Good apps do, yeah. They'll show you a timeline with markers for motion events, letting you jump straight to the relevant clips. It combines the live view, the alerts, the recording control, and the playback all in one place.
That makes sense. It ties everything together. Now, before we wrap up, you mentioned earlier that ONVIF opened the door for different types of apps.
Right. Broadly, you've got two camps. First, the vendor-specific apps. These are made by the camera manufacturers themselves. Think Hikvision's HikeConnect, Dawa's DMSS, Reolink's app, and so on. They're usually tightly integrated with their own hardware features.
Okay. And the second camp?
Those are the third-party multi-brand viewers. Apps like iCam Viewer, IPCam Viewer Pro, maybe open source options like iSpy or ZoneMinder accessed via an app, DeskShare's IP Camera Viewer. there are quite a few.
And these exist primarily because of standards like ONVIF.
Pretty much. They aim to give you a single interface to view and manage cameras from different manufacturers all in one app. Really useful if you have a mix of brands or just prefer an interface that isn't tied to one company.
So lots of options depending on your setup and preferences.
Definitely. So if we try to synthesize all of this, what really makes these IP camera viewer apps powerful is their sort of technical versatility.
How do you mean?
Well, they have to juggle all those network details, IP addresses, ports. They need to speak the right protocols, like RTSP. They leverage those crucial standards, especially ONVIF, to work with diverse hardware.
Right.
And then they build that bridge for remote access, giving you the choice between that easy, cloud-based P2P.
Or the more complex but direct port forwarding and DDNS route.
Exactly. They handle all that complexity under the hood to deliver that seemingly simple live video feed to your pocket.
And knowing how that works, understanding those two different remote access methods especially, really helps you make smarter choices when you're setting up your own system, doesn't it?
It absolutely does. You're not just buying a camera, you're choosing how you want to connect to it, how much control you want, and what kind of dependencies you're comfortable with.
Are you okay with the PDP convenience and its reliance on the manufacturer's cloud? Or do you value that technical independence enough to tackle port forwarding? Understanding that fundamental difference, well, it changes how you approach your security.
It empowers you to make a more informed decision.
Which leads us nicely into a final thought for you, the listener, to mull over. We've talked a lot today about the mechanics, particularly those two distinct ways to get remote access. The simple, cloud-mediated PDP versus the technical, user-controlled port forwarding DDNS method.
With a core trade-off.
So the question to ponder is this. If absolute performance, lowest possible latency, and long-term reliability, completely independent of any third-party cloud service, were your absolute top priorities, which remote access method would you personally invest the time and, let's face it, the technical effort into setting up for your own system, PDP or port forwarding DDNS? And more importantly, why would you make that choice?